Alrighty then, so I want to talk about geometric series. So what I've done here is I've written out the equation. If I wanted to find the sum of the first n terms, well, I've written out what the first n terms will look like. The first one would be a1. Then to get the next one, we take that a1 and multiply it by r. So what after that would be a1 times r, or times r squared. And a1 times r to the third, so on and so forth until I get to my nth term, which would be a1 times r to the n minus 1. So when we looked at arithmetic series, there's a nice handy trick for how we figured out the formula. And there's another trick here. What we're going to do is we're going to take everything in this row and multiply it by negative r. I may need to get a different marker. I don't think this one's going to work out so well for me. So I'm going to multiply everything in this row by negative r. And it turns out what I'm going to get is, well, a1 times negative r would be negative a1 times r. And then a1 times r times negative r, and negative a1 times r squared. And eventually you'll see the pattern here. If I take the term right before this one, it would give me, we'll do it this way, negative a1 times r to the n minus 1. And then multiplying this term here by r, I get a1 times r to the n. And so the trick here comes in when we add these two rows together. So on the left side of my equation, I'm going to have Sn plus negative r Sn. And on the right side, well, a1, I'm going to get that. But all these other terms here are going to cancel out. a1 times r minus a1 times r, that cancels. This part here cancels and cancels and cancels. So I get to the very end of this equation where I have a1 times r to the n. Alright? Then what I can do now is on the left side I'm going to factor out an Sn. And on the right side I'm going to factor out an a1. And then finally I can solve for Sn and see that my formula to find the sum of a geometric series, if I divide both sides by 1 minus r, would be a1 times 1 minus r to the n all over 1 minus r. Alright, so this is the formula that you will use to find the sum of the first n terms of a geometric series. It's a pretty neat formula. Turns out something kind of cool happens because there's a couple different kinds of series that you can look at. So for example, one type you might see would be the one that stops. For example, maybe our series looks like this. We've got 1 plus 3 plus 9 plus 27 plus 81 plus 243. Alright, and it stops there. So here my first term, my a1, is 1. My common ratio, what I'm multiplying by every time, is 3. And the number of terms I have, well, 1, 2, 3, 4, 5, 6. I have 6 terms. So the sum of those first 6 terms, rather than adding these numbers all up, I can just use the formula. So it'd be a1 times 1 minus r to the n power all over 1 minus r. Alright, so I didn't even know what 3 to the 6th is. Well, I know this is 3 to the 1st, 2nd, 3rd, 4th, 5th. If I multiply that by 3 again, I'll get 3 to the 6th. So 729. So this is going to be 1 times 1 minus 729 all over 1 minus 2, which works out to be negative 728 over, over negative 2, which should come out to be a whole number since it is the sum of a sequence, or the sum of a series. So if I do the division here, let's see, 364, is that right? Hope so. So if I add up all these numbers, I should be able to get 364. The formula here is just a nice shortcut, especially if you have a long series where it'd be really tedious to type those into the calculator or to try to add them up by hand. Having the shortcut there is really nice. Another thing that's pretty cool with this formula that we can do is, let's say that our series doesn't stop. Well, then we have two situations. Either our series is going to diverge, meaning it's going to go off to either positive or negative infinity, or it's going to converge, meaning that it will go off to some value, we'll call it b. So either it approaches positive or negative infinity, or it converges to be a specific value. So when does it diverge? Well, it diverges when the ratio is bigger than 1 or less than negative 1. It converges whenever it's somewhere in between those two numbers. And I think that I might have the multiplied by 1. Yeah, I should have the symbols like this. So if r is greater than or equal to 1, or if it's less than or equal to negative 1, the series is going to diverge. It'll go off to positive infinity or negative infinity, depending on which one you're looking at. If r is between negative 1 and 1, it's going to converge. So for example, just to show you one that does converge, let's look at the sequence 16, 4, 1, 1/4, dot, 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 dot. And what happens there? So it turns out, if we look at our formula real quick, Sn equals A1 times 1 minus r to the n all over 1 minus r. The tricky part comes in with the n. Obviously, if this series goes on and on forever, n is going to be infinity. So the thing we're really worried about is what happens as we raise that r value to the infinity power. So in this example here, r is 1/4. If I take 1/4 and I raise it to the 10th power, not quite infinity, but still a reasonably large amount, turns out I get something like 0.000006. If I raise it to the 100th, instead of 6 zeros, I believe I get 60 zeros. So a whole lot. And that's just to 100. So imagine if I raise it to the infinity, something huge, insanely big. Well, this is going to be almost 0. So what happens is, as n gets really, really big, this term here becomes 0. And 1 minus 0, well, that's just 1. And 1 times a1 is just a1. So if n is infinity, and if r is between, do it this way, if r is between negative 1 and 1, then this becomes the equation used to find the sum. So for example here, a1 is 16, the ratio is 1/4, so 1 minus 1/4, well, that's 16 over 3/4, which is 16 times 4 over 3, which is 64 thirds. So whatever 64 thirds works out to be, that would be what this series sums up to. So it's pretty cool the way it works out. So hopefully that was informative. If you have any questions, let me know.